Okay, this is the video tutorial that goes with lesson 1B.5, actually, not B1.5. We're going to look at some more word problems. We looked at a few last lesson, but we're going to look at very specific ones for this one involving perimeter and area. We're going to look at how we would create these and then how we would solve these equations. So this lesson will also be the review lesson as well, and we'll cover that in a separate video. There was a warm-up for this lesson, just to review the work from lesson on B.4, and it's to do with proportions. So our proportions questions are where we have two fractions, fraction equals fraction, and we're looking at cross multiplying or using that butterfly method, as some of you learned when you were in middle school. So by putting the loops in, you can see which things you're multiplying together. It doesn't really matter which loop you do first, whether you do this one or this one. I think I actually did this one this time, so let's just have a look. Notice around the one with two terms, I do put parentheses, and that's really important. And same for this one, 4 times x plus 3, or x plus 3, but I put the x plus 3 in parentheses there. If you were to have the x plus 3 here and the 4 here, rather than putting x plus 3 times 4, like this, that kind of looks a little bit confusing. I think I would just go ahead and switch them using that commutative rule. I always tend to put the numbers first and then the variables second. So when you're multiplying, it doesn't matter which order you do that. Now from here, we can just use our distributive rule. So 5 times 2x is 10x, and 5 times -1 is -5. Any you're not sure of, just go ahead and use your calculator just to double check. 4 times x is 4x. And 4 times 3 is 12. So if you're not sure with this, obviously you can't type 5 times 2x on your calculator. You just have to do the 5 times 2. And then as there's an x there, you can add that in. Now, once we're at this stage, notice we have variables on both sides here. We have numbers on both sides. So normally I prefer to move my variables to the left. So this 4x, we've got to be careful we don't divide by 4. A lot of people started to drop into that habit. This is a positive 4x. So when we bring it to the other side, it's going to become a -4x. I think what people are remembering is that very last stage when you just have a single variable. But when we have two variables like this, we're just adding and subtracting at this point. So 10 take away 4 gives me 6x. -5, I just copy that down. And then this positive 12, I'm just going to write as 12 at this point. If you put positive 12, it's not incorrect. And then to move the -5 to the other side, as I brought my letters to the left, I want to bring my numbers to the right. So I can add 5 to both sides. And 12 add 5 is 17. And then the final stage then, instead of timesing by 6, I would divide by 6. So that's the term when we do the division. Notice there's only one variable on this line. And this line up here, there's 2 lines. So we're adding or subtracting, just combine our like terms first. And 17 over 6, check it on Desmos. It will give you a decimal, hit that fraction button, and it will actually say for this one, it is just 17 over 6. It doesn't actually simplify, so that's as far as we can go. But deliberately picked one with not particularly a nice number here, just to remind us that the reason why we follow these steps. For questions that are particularly difficult, it's really important we have a good algebraic method, because we can't just look at a question like this and see that the answer is 17 over 6. Time for that reminder, as we've had most lessons, don't forget the special cases. Sometimes when we have the same number of x's on both sides and the x's cancel, we just get left with numbers. When we get left with the same number, we say infinite solutions. So for example, 0 equals 0. Or if we get different numbers because the x's cancel, like 0 equals 2. Does 0 equal 2? No. So we will say no solution. On this one, does 0 equal 0? Yes. So in other words, don't pick the one that says no solution. Just to give you a quick example of how that might look, 2 times 3x is 6x. 2 times 1 is 2. 6 times x is 6x. 6 times 2 is 12. So they'll often put questions in with parentheses to try and disguise the fact that they have the same number of x's on both sides. So right here, it doesn't necessarily look like the same, but you can see that they are. If I take away 6x from both sides now, I get left with 2 equals 12. Does 2 equal 12? No. So my answer for this one would just be no solution, like you can see at the top there. Oops. One more line there. There you go. So this one will be no solution. If it was an example, like if I put 6 here, 2 times 6 would be 12. Does 12 equal 12? Yes, it does. And I'll be picking infinite solutions. So we talked a little bit about perimeter in one of the early lessons. We didn't really do a proper question on it. So we're going to take a look now. If the perimeter of the following shape is 36, what is the value of x? And you can see that the rectangle is drawn here, and you can see the two sides that are labeled. So perimeter is the distance around the outside of the shape, and therefore we're going to add up all the lengths together. Now, on the picture, they typically only give you two of the lengths, but I would expect you to know the top is going to be the same length as the bottom, and the right-hand side is going to be the same length as the left-hand side. So that's how we would start. We would label all the sides, and then we're going to add them all together. Now, I've added parentheses in here just to try and make it clear exactly what's going on here. So I've had the top side plus this right-hand side plus the bottom side plus this side over here. And in the original question, it said the perimeter is 36. So remember that word is a clue for us that it's going to be equal to 36. Now, this is where I don't want to be doing opposites because I already have my x's on the same side here. I just want to collect terms here. So I got 5x plus 3x, which is 8x. Add 5x, which is 13x, and then add 3x, which is 16x. And if I have positive 3 add negative 1, that gives me positive 2. Add positive 3 is positive 5, and then add negative 1 is positive 4. And any we're not sure of, we can just go ahead and use our calculators. Equals 36, equals 36. And then from here, this should be something that's fairly easy to solve. So although it starts off as something very complicated, we can actually quickly come up with the answer. Now, I wouldn't normally actually even write this down. I would really just kind of look at the picture and work out what my like terms are. So 5 add 5 is 10, add 3 is 16. Add 3 is 13, and then add the other 3 is 16. And then from here, 3 add 3 is 6, take away 1 is 5, take away 1 is 4, and then 4 being positive 4, of course, and then I can just write this straight down. But just so you can see technically what we're actually doing on this question, we're adding all these 4 terms together. And then we can take away 4 from both sides. That cancels, and 36 take away 4 is 32, and then divide both sides by 16 to get the answer of 2. Sometimes they'll ask you what the length of each side is. If that's true, you can just substitute back for 2. So 5 times 2 is 10, add 3 is 13. So the top of the rectangle is 13, 3 times 2 is 6, minus 1 is 5, so the height of the rectangle is 5, just in case they ask. Now, if you weren't in class, I would recommend pausing the video at this point and having a try on this question. Same idea, it talks about perimeter. We're going to add all the sides together, and this time it's going to equal 33. All right, let's have a try then. So this is what we're actually doing. I'm physically adding all these together. So 3y plus 3y plus, remember y means 1y. So this would be 3 add 3 is 6, add 1 is 7. So I'd have 7y. 2 take away 1 is 1. Plus positive 4 is 5, so positive 5 here equals 33. Take away 5 from both sides, so that cancels. And if you do 33, take away 5, you get 28. Divide both sides by 7, and from here you can probably see 7 times 4 is 28 anyway. Now, I did throw in this question this time, how long is the longest side? So if we know that y is 4, 4 add 4 is obviously 8. 3 times 4 is 12, minus 1 would be 11. And 3 times 4 is 12, plus 2 is 14. So how long is the longest side? Well, clearly 14 is the biggest of those numbers. From the picture, you can kind of tell, but they don't always draw pictures to scale that this probably was the longest side. But probably easier just to do that quick little check, just so you can find out. So that's the questions on perimeter. Important we don't mix it up, though, with area. So when we're finding the area of a shape, that's how much space is kind of inside the shape. So perimeter is the distance around the outside. Perimeter is how much on the inside. And for perimeter, it's actually on the formula sheet for the SOL. You do base times height. You multiply these two numbers together. So writing that out, and this is from the formula sheet, base times height, I'm going to do this times this. But once again, I'm putting my number first and my variable second. And notice, just like when we did the question earlier, I actually added in my parentheses here. So if I go back to this question, notice there's no parentheses in this question, but when I did my multiplication out, then there was parentheses in here. So I'm doing this times this equals 52. I'm going to go ahead and distribute. Notice you could actually just divide both sides by 4 at this stage as well. But when we see parentheses, generally people prefer to distribute. So we're going to do the same thing here. And then I can take away 12 from both sides. Take away 12, take away 12. That one cancels because I did the opposite, and then work out 52 minus 12. And then last step, we can divide both sides by 20. And 40 divided by 20 is 2, just like you can see at the bottom there. And if you wanted to substitute back, you could as well. And that's 5 times 2 is 10, add 3 is 13, and 4 times 13 is definitely 52, which it says in the question. So I know I got this one correct. If you want a quick chat practice at perimeter, there are a few questions you can try here. Pause the video, and then in a few seconds, I'll go ahead and reveal those answers. And there's the answers if you wanted to check to see if you were actually understanding what that actually is. That does it for perimeter. There is one additional question at the bottom. I think that's probably an extension question that's probably a little over the top. So we'll leave that one for right now. And that'll do it for this video.